All right, good afternoon, everybody. Hope that food baby's kind of passing through you right now and you kind of got your energy back a little bit. My name is Brad Jorn. I am a soil scientist on the Radicle Agronomics team, and I'll be joined on the stage today by Adam Viccari, who is the lead engineer for the Radicle Lab, as well as Cory Muhlbauer, who's one of our outstanding research agronomists here at Precision Planting. And we're going to share some of our concepts and tools to help you better manage your fertilizer dollar. I mean, after all, in a corn-soybean system, you're spending more money on fertilizer than any other non-land input cost for your crops. And, you know, I mentioned Radicle Agronomics. How many of you know what Radicle Agronomics is? Okay, a few of you, but not very many. So Radicle Agronomics is more than just this fancy automated soil testing lab. It's really an ecosystem, and Adam's going to show you some of the parts of our hardware ecosystem. You know, we're coupling better tools there. We're developing a modern crop response database, and I'm hoping some of you will consider participating in that with us because we need your help. And we're coupling all that together with the Radicle App, which is a piece of software that will link the data back to the tools to help you make a better recommendation system, whether you're doing it yourself or you're working with some agricultural professional. If you think about nutrient management and the nutrient management cycle today, there's opportunities everywhere. And so I'm going to talk to you a little bit about the current state of fertilizer recommendations, the different kind of systems that are out there, how variable it is from one state to another. Then Adam's going to talk to you a little bit about the soil collection process and also the soil testing and analysis. And then Cory's going to finish us off with management things to increase that fertilizer use efficiency. So talking about placement, products, timing, things like that. So my challenge to you in my 15 minutes, my little section is I want you to take a little more ownership of how you're spending that fertilizer dollar. You know, you think it's really complicated. I mean, in the fine details it is, but the way we manage nutrients today, you can take ownership of a broken system and make it better. And then I'm hoping that you'll see the value of conducting some research, and we'll support you on that to see what works best for your farm, your soils, your management. Okay? So when it comes to fertilizer recommendations, there's really two kind of primary schools of thought. One of them is called the build-up and maintenance approach to making fertilizer recommendations. That's used a lot in the Midwest, but it's not the only system. The other system is the sufficiency-based system. And so I'm going to show you a couple of examples, and then I'm going to show you a bunch of examples. Okay? So the example build-up and maintenance recommendation I'm going to show you is going to come from the University of Illinois. And this recommendation is a phosphorus recommendation for 215 bushel per acre corn. So on that horizontal axis is your soil test value. It's either Bray P1 or Malick 3 colorimetric analysis. And then on that vertical axis is your P2O5 rate in pounds of P2O5 per acre. And so that line that you see there is where your soil test intersects with that line, gives you the fertilizer rate recommendation. Now, the buildup and maintenance approach, you can kind of think of it, I'm going to feed the soil and let the soil then feed the crop. And so there's a couple of concepts we have to be aware of. One of them is the concept of a critical soil test value. Now, that's the soil test value. In this case, it's 25 parts per million, but that's the soil test value at which 80% of the time you wouldn't expect to get a crop response to applying a nutrient if you're at that soil test level or greater. So like 1 out of 5 years, you might get a response, but it would be a fairly small response and it would be overcome by a pretty low rate of fertilizer. As you increase your soil test beyond that critical level, you approach what's called the maintenance limit. That's the soil test level at which the university researchers have decided that it doesn't make any economic sense for you to have a soil test level higher than that because you're not going to get a crop response. And you know, in the case of phosphorus, because it causes algae blooms in surface waters, you start getting way out there, then you can start having potential runoff issues and things like that. Now, between those two values is the maintenance range, right? So between the critical level and the maintenance limit, you're applying the same rate of fertilizer. And that fertilizer rate is designed to maintain that soil test value wherever it is. That's usually a crop removal rate. Now, if you're below that critical soil test level, then you're in the buildup component of the fertilizer recommendation. And that rate is the maintenance rate plus looking at the soil test level where you're at, trying to get it to the critical soil test level in a specific period of years. Most universities use a 4-year buildup. And the slope of that line is also based on what we call the buffer capacity, or how much phosphorus does it take to increase your soil test by 1 part per million, right? So that's kind of how this recommendation system is built. Now, the sufficiency-based recommendation system, and I'm using Kansas State's sufficiency-based recommendation here, again for 215 bushel per acre corn. Kansas State actually has both a sufficiency-based recommendation program and a buildup and maintenance recommendation program. But in the sufficiency-based program, we don't really care about the soil test level. We say, what is my soil test level, and how much fertilizer do I need to maximize yields of my crop this year? Most of the time, that's going to be below the crop removal value. So if you're below the crop removal value, that means your soil test level is going to go down. In this case, it's going to go down to about 4 parts per million if you follow that recommendation system, because that's where your crop removal rate intersects that line. I'm not very comfortable getting our soil test levels that low, because our own research in Illinois has shown that once you get to around 10 parts per million, you need more than crop removal to boost your yields to a maximum. But if you look at that, these are kind of the opposite ends of the spectrum. Sufficiency fertilizer recommendations are a lot cheaper than buildup and maintenance. So if you're below the critical level, you're going to spend $80 more per acre using a buildup and maintenance approach than you are a sufficiency-based approach. And then once you're above the critical level, it's going to be about $65 an acre. Okay? So what I've done is I've programmed, we have 10 locations where Winter Conference 2025 is being broadcast to. So I programmed all of the fertilizer recommendations from land-grant university for 215 bushel per acre corn, and I graphed them. Okay? I did that for all the states except 2. One of them is Virginia. It was the 10th state that was, became part of the United States, 10th state to join the Union. And then also my apologies to my friends in Kitchener, Ontario. I mean, I know that they're all jazzed up about becoming the 51st state in the Union, but I didn't get theirs programmed either. Now, you got to realize Canada has 10 provinces, so they can't just become the 51st state. They'd have to be the 51st through the 60th state, right? So anyway, enough politics. Politics aside, I want you to think about the concept of pickup sticks, okay? Now, this is what we used to have to play with when I was a kid, because we didn't have computers back then. Not going to teach you the game. I just want you to imagine this, because now I'm going to show you the fertilizer recommendations for all the land-grant universities where we have satellite locations for Winter Conference 2025. It kind of looks like pickup sticks to me. I mean, most things are in a straight line, but you got to remember something. There's no university soil fertility specialist that is going to provide a fertilizer recommendation to their clientele that's going to short them on yield, okay? Because you'd lose all credibility. So that means if nobody's wrong, there's a lot of ways to be right. So don't be so beholden to the fertilizer recommendation system in your own state. Illinois just happens to be the highest of anybody that's participating this year. But Indiana's lower, and I'll go through an example there. So just think about that and say, there's a lot of opportunities that I can take advantage of to maximize the return on my fertilizer dollar. I don't have to be beholden to the state land-grant university system. Just to show you, potassium recommendations are no different. Nobody is wrong, a lot of ways to be right. I don't like the buildup and maintenance system. The reason I don't like it is because it has no place, in my opinion, in precision soil fertility. Why would I build my soil test level up to the critical level, which is 25 parts per million, and if I start out at the high end, draw it down to 35 parts per million, and between 25 and 35, apply the same rate of fertilizer. That's not precision soil fertility. Plus, it cost me $125 per acre to increase my soil test 10 parts per million with today's fertilizer prices. So why would I do it? Okay? If you look at all of the states, you can figure out pretty quickly that the critical soil test value is somewhere between 15 and 25 parts per million for all states. Okay? So I like the concept of what I call a targeted soil test-based system. Now, I have the tri-state recommendations. You know, I was a professor at Purdue University for 26 years, so I'm pretty familiar with that recommendation system. And then I have the University of Illinois recommendation system. Who has better soils, Illinois or Indiana? Illinois, right? So why do you have to apply more fertilizer in Illinois to grow the same crop than you do in Indiana? Doesn't make sense to me, okay? Now, the difference between the height of that maintenance rate is the difference between what Illinois says a crop removes versus what Indiana says. Well, Illinois' fertilizer recommendations were based on a bushel of corn removing 0.43 pounds of P2O5 per acre. Indiana is based on bushel of corn removing 0.35 bushels per acre. Well, in 2016, Illinois did its own internal study and found out, well, geez, our real number is 0.37, not 0.43. So they just haven't changed the fertilizer recommendations yet. I mean, the next Illinois Agronomy Handbook, these will jump down to about what the Indiana or tri-state recommendations are. Lonnie's laughing. Okay, so I'm going to base my recommendation system on the tri-state removal system, right? So I don't want to take any chances. I want my soil test level to be 25 parts per million because I don't believe what the tri-state recommendations, because they're down at 15. You know, we grow better corn than they do, and so I'm thinking it's because of the fertilizer recommendations. I'm going to stick up in the 25 ppm range. Conversely, Brad Jorn really knows what he's talking about. That guy from Purdue, that guy has got it going on. I'm going to follow his recommendation system, and I'm going to target 15 parts per million as my target soil test level. Maybe I'm kind of wishy-washy about it. I want to be a moderate risk taker, so maybe I want my target soil test to be 20 parts per million. But you see, all of those eliminate that buildup range. You are trying to hit a target soil test level. Is it 15 parts per million? Is it 20 or is it 25? Just think about that and think about where are you on that risk aversion scale? Where would you like to be? Let's put this in an example. I got a quarter section, 160 acres, square quarter section, 2.5 acre grids, 64 grids. I've just got this land. It was managed with uniform P applications for about 25 years. And over time, my soil tests have begun to vary because of variable yield, right? So I have higher soil test values in the low areas of my field where it gets drowned out occasionally, and also higher soil test areas, maybe on the eroded knob up on a hill or something like that, where I also have lower crop yields. And so this maybe is what my map looks like, right? Higher soil test areas in the blue areas, which is the lower areas of my field, and also in the red area, which is the higher areas of my field, okay, more droughty. If I look at the variability in soil tests across that field, it goes from 16 to 38 parts per million. That's a pretty wide range of phosphorus soil test values. Well, let's say I want to adopt a different fertilizer recommendation program. All right, so I've got MAP at $810 a ton. That's 70 cents a pound of P2O5, the way I calculated it. Now, University of Illinois, I'm going to take any soil test value less than 25, I'm going to bring it up to 25. Any soil test value greater than 35, I'm going to draw it down to 35. Anything between 25 and 35, I'm going to keep the same. Okay? That's what my map would turn into. It looks a little more uniform, but it's still kind of variable. It's going to cost me $15 per acre to make that soil test change. Okay? So $2,400 per field. Well, let's say I want to use that targeted soil test approach, and I'm not a risk taker. I'm going for the high target soil test level of 25 parts per million. So theoretically, that's what my field's going to look like. Uniform 25 part per million. That's going to actually save me $16 an acre. Okay, $2,500 a field. Now let's say that I've done my own crop response research, or Radicle Agronomics team has done crop response research and finds out that, you know, in these lower areas of the field where I have higher organic matter, higher water holding capacity, you know, phosphorus is delivered to the plant via diffusion, so moisture has a lot to do with nutrient availability. I can get by with a lower soil test level. So there I'm going to target 15 parts per million. Conversely, on the red area of my field, it gets droughty, I'm run out of water, so I don't get to extract phosphorus from the entire soil volume because there's air spaces in there. Then maybe I want 25 parts per million. And in the center section, I'll go with 20 parts per million, right? So I have variable soil test targets. Now this starts to look like precision soil fertility to me, right? And if that works, I just saved 84 bucks an acre to modify my soil test values, okay? Now once I get there, then everything costs the same because I'm applying a maintenance rate of fertilizer at whatever my soil test target is. But that's the opportunity for savings based on how you decide to manage. Now, if you want to get into the precision fertility business, it requires two things. One of them is a repeatable lab, and the other one is a justification for having different soil test target levels. So we did a repeatability study last year where we went to a few different fields, we collected a bunch of soil, then we homogenized all that soil, and then we vacuum sealed bags of that soil and stuck it in the freezer. And every 3 weeks, we took 3 bags of each soil and sent it to 3 different labs. So each time we sent it, each lab got 3 shots at giving us a soil test value. And we did that 6 times. So that means each lab had the ability to sample the same soil and give me a soil test result back 18 different times. And I want to see how repeatable is that lab. Okay? So I'm going to show you the difference between the lowest soil test value and the highest soil test value for each of these labs. Now, these are not Walter Weiss labs where they're in the back of the RV making meth or something like that. You know, they're not from Breaking Bad. These are the big commercial soil testing labs in the Midwest. Okay? So in one of these soils, out of 18 times, lab 1 only varied by 3 parts per million. Okay? Now our fertilizer recommendation with a straight line, each 5 part per million increase in soil test gives you a 25 pound per acre change in rate. Okay? So each part per million is a 5 pound per acre rate change. And at 70 cents a pound, that's $3.50. So if I'm off by 3 parts per million, my fertilizer recommendation could vary by about $10.50. The second lab was 13. Okay, that's $45 an acre. The third lab was 14. Okay, that's almost $50 per acre. So if you're going to marry your management to your soil test result, you've got a fluctuation of pretty close to $50 per acre if you happen to get the wrong result back. Okay, this other field, look at lab 3, 26 parts per million. I mean, that pretty much covers from 0 to 25 parts per million, right? It more than covers that. And so that's a $90 per acre change in your fertilizer recommendation because of lab repeatability. So let's throw the Radicle Lab in here. So the Radicle Lab is a fully automated lab. So in the first field, we had 1 part per million change out of 18 shots at it. And in the second field, it was 2 parts per million. That's the repeatability you need for precision fertility. The other thing you need to have is some reason to have different target soil test levels. Right? So we're doing a lot of crop response research. We're doing it in the lab, we're doing it in the greenhouse. So we're looking at that buffer capacity, like how many pounds of P2O5 do you need to get a 1 part per million change in your soil test level, right? We're looking at that. We're doing crop response trials in the field and saying, at a given soil test level, how much fertilizer do I need to maximize yields? So we're going to determine the critical soil test value. We're going to determine the rate you need at any given soil test value, build that into part of the database. And we have these Generation 1 and Generation 2 trials. And these are the trials that you can participate in, and we will support you with that. And Adam's going to kind of give you a QR code in a little bit so you can sign up just to learn a little bit more about it. You're not making any big commitment or anything, but I want you to think about that. Take ownership of your fertilizer recommendation. and consider doing research on your own farm to see what works best with your equipment, management, products, etc. So with that, I'm going to turn it over to Adam, and he's going to tell you all about the Radicle Agronomics Lab.
Thanks, Brad. Start off with a question for everyone in the room. How many people have soil sampled their own fields? Anyone out there doing it? A few people? A few people? If you have, you know there's a decent amount to understand and to get it set up to pull that off. You need to be familiar with the GIS software and how you want to sample those fields and implement grids or zones, set up your target points for how you want to go out in the field and take your cores. Once you have that set up, you need to transfer that over to a piece of software to use on your vehicle that you're using to go navigate your field. Once you get out to the field and actually start taking your cores, you get to deal with soil bags. Soil bags, you're familiar with them. They're another thing that needs to be labeled, managed, organized. Once you're done in the field, you can come back to the shop and work on your lab submittal sheets. And then you can arrange getting your samples shipped off to the lab or dropped off, depending on your location. And then depending what the lab has going on, you're waiting for the results to come back in. And then once the results come back in, you can import them and then work on your recommendation. So again, these are not difficult steps. There's just many points of friction that you have to figure out if you want to be in the game of doing your own soil sampling. Brad mentioned Radicle Agronomics. One of the goals of our system is to make that process more efficient, more seamless for you, from deciding to sample your field to actually getting that lab result back to you by eliminating a lot of those additional steps. The other thing I'm going to talk about in my talk, besides the tools on how we can make that process more efficient, is how the Radicle Lab differs from a traditional soil lab and what those differences are that helps us give a more repeatable soil test result. I showed you the soil bag. In order to automate some of the processes in the field with GeoPress and in the shop with Radicle Lab, we had to come up with a new soil container. We call it GeoTube. GeoTube is a robust, reusable container, and one of the unique features it has is an RFID tag on the bottom of the tube. What this allows us to do in the field is GeoPress can automatically write to that tag and associate that tube with your location in your field. So it does the georeferencing for you automatically, so you don't have to label or manage the soil bags. Since the tube is reusable, we also have a plunger when it goes through the Radicle Lab. That plunger has a unique design that helps take all the soil off the side of the tube, and then it's also washed in the Radicle Lab and the cap is put on. So you don't have to do any additional work to keep that tube clean as you take it from the lab back out to the field again. When you are in the field, we have GeoPress. GeoPress is your in-field assistant. It mounts on a UTV and communicates over Bluetooth to Radicle App that's running on your tablet. So you'll use the Radicle App to navigate to your location in the field. And then when you get out and collect your soil cores, depending if you're doing grids or zones or doing hand probe or hydraulic probe, one challenge you have is in order to get a representative sample for that grid or zone, you need to thoroughly mix up those cores. When you send them to the lab, we want it to be a thorough mix. So that's the first thing GeoPress helps do for you is it has a mixer built into it. And as the cores are pressed in, it will run, and then you'll end up with finely blended sample that's ready to go into the soil container. So number two, GeoPress can automatically take the cap off that GeoTube, press the soil into it, and put the cap back on. So you don't have to do any handling to get it into the soil container. And the third things I mentioned is GeoPress will automatically write to that RFID tag on the bottom of the GeoTube, making the link between this soil sample in the GeoTube and your location in the field. Again, automated record keeping is better record keeping. These steps aren't hard, you have to do it over and over again. So anything we can do to automate that process and make it more efficient can help not only have better quality and traceability in the field, but also let your mind free to worry about other things that are more pressing. Once you have your sample in the field, and it's in geotubes, you're ready to come back to a local Radicle Lab. Again, we're envisioning a network of these available for you to drop off, and it's designed to run in your shop, an automated soil lab designed to run in a shop. It has a 400 tube capacity, you can see it over here, and it runs about 200 samples a day. What do you need to run it? It's about a 12 by 14 area, and then you need an air compressor, 240 volts, and a water hose. We take care of all the filtration and quality assurance of those inputs. It's built into the system. So it is designed to be easy to hook up and get running. Once you've analyzed those results, the results are, it's an internet-connected device, and those results go up to the Radicle App and the Radicle Cloud, and you're able to see your soil results and export those to make your recommendations. For 2025, we're offering the following analyses. We have phosphorus, potassium, calcium, magnesium, pH, and a buffer pH, and then we can also calculate CEC and base saturations. I mentioned it, but tying all of the pieces together in the field or in the shop with the lab is the Radicle App, and it's available on a desktop, on your mobile phone or tablet for when you're in the field, and all that data seamlessly interconnects through that. And it's available at no additional subscription cost, and the goal of the platform is to keep everyone involved in the process or managing your fields in the loop, whether they're actually in the field or not in the field. So those are some of the tools. Let's walk through an example how you'd set it up, a field, sample it, and then run the result. And I'll show you in real time here what the GeoPress and the lab look like. So step number one is we need to create a sampling plan. So this is done with the Radicle App. If you have this information, a boundary you might already have as a shapefile, that can be imported. You can also drive the boundary or draw the boundary. Once you have the boundary set up, you need to decide if you want to be importing zones. You can use Radicle App to create grids, adjust your target points, and then once you have that set up, you're ready to go. And again, that, as long as you're connected to the internet, that's available to the GeoPress in the field, and you're ready to go sample. So step two, sample in the field. And so I'm going to walk off stage here, and I'll show you the GeoPress. So you're going to be using the Radicle App to navigate to your locations where you want to take your target points. Once you get there, you can start collecting your cores. And then what you'll do is, once you've collected your cores, you're ready to run them through the GeoPress. And so what I'm going to do is, first you'll open the hopper here, and then what you'll find is the cores go into the hopper and then they come out blended. So when I shut the hopper, that'll start the mixer running, and it'll keep running until I pull the mug out. So again, we're able to blend up the cores here to get a representative sample from that grid or zone, and now we're ready to get it into the GeoPress. And again, as soon as you start lifting up that funnel, GeoPress will start working on putting that soil into the geotube, putting the cap back on, and you're jumping back into the driver's seat and you're heading to the next sample. So while GeoPress is working on finishing up the details, you're already navigating to your next point. Maybe you're out taking your cores. So just making the best use of your time. Once you finish in the field, you'll come back with a collection of geotubes, and these are ready to go back on the Radicle Lab. So one new thing for this year is GeoPress works great for a UTV, but if you're on a four-wheeler or you have other things in your UTV, maybe you have a hydraulic probe in your passenger seat, it has a space claim that you might want something a little bit lighter. So for lack of a better name, new for 2025, we have a new option to join the GeoPress family that we call GeoPress LITE. What GeoPress LITE is it has a separate plunging and mixing station, so it's more configurable. Can go on a four-wheeler, or depending on what your sampling vehicle looks like, you can adjust it. And it has an integrated RFID writer for the geotag, and is compatible with GeoTube. So the thought being on this one is we're trading some of the automation for you manually operating, performing these steps, but we can have a more cost-effective way to get you on the platform. So I'll walk you through what this might look like. You'd have your geotube, essentially like a bottle opener, and then you would put the geotube in here and put it in position, and then you would introduce the soil, and this would plunge it, and then you'd be ready to come back out and put the cap back on, if I didn't lose it. And then you're ready to go back on the lab. So if you don't have butterfingers, you won't lose any samples. So excited to have that, and I think it just opens up more options for how you can get involved with the platform. So once you have your geotube, that's ready to go on the Radicle Lab, and you might be dropping this off at your agronomist shop or wherever the Radicle Lab is located locally. Again, they can be ran in any order. In the same way you would start your dishwasher, you know, there's a play button and we start analysis, and that'll kick it off. It'll do what it needs to do, and it'll start processing your samples. So while that starts processing that sample, I'm going to walk through a few differences, how the Radicle Lab is different from a traditional soil lab. So we read that RFID tag again, and then we start processing. One unique difference is we're using a moist sample from a field, and we are using the whole sample in the geotube, and it gets mixed together. In a traditional soil lab, you would oven dry the samples, run it through a hammer mill to mix it up, and then you would take your subsample. We want a moist sample, and we want all of the sample, and that'll give us the most repeatable result. Here's from one of our demo stands where we are mixing green food coloring. So again, we want to thoroughly mix everything again. So the sample is plunged, we add water, and then again, to avoid taking a subsample that might be a little bit high or a little bit low, we do a thorough job of mixing everything. After that step, we're ready to take our subsample for analysis. Again, in a traditional soil lab, a 2-gram scoop is one way of doing it. And what that is you're using a volumetric measurement, a spoon essentially, to try and approximate a mass measurement. And where this gets you into trouble is you have to assume a soil density. And there's no two soil densities that are the same. So if you had a high organic matter versus a heavy sand, that will give you inaccuracies in your lab results by assuming what the density of that is. To avoid that, Radicle Lab uses a series of measurements, but we do a true mass reading of it. And when we take our subsample, then we're helping eliminating errors due to these soil densities. Once we're ready for analysis, there's many, many steps that have to be done very precisely by trained laboratory technicians if you're doing this in a soil lab. One way we go to raise the bar on repeatability and accuracy is we've automated this with technology that we call microflow. Microflow, developed here in Tremont, Illinois, is a microfluidic manifold that is controlled by software and is automated to perform the same measurements the same way every time. It can very precisely volumize soil and chemical, mix those together, control the filtration times, and that helps lead to a more repeatable result. Brad mentioned this, but once the lab has given you a result, you know you have so many ppm, how do you know what to do with that? And that's where we're really excited to have the opportunity to partner with you, if you're interested, and keep expanding our crop response trials. Shown on the green pins here are all the places we have trials going on, but really what we want to understand is what is the right soil nutrient level for your field? And we have protocols and agronomists in place to help make this happen. So if you're interested in getting involved with Radicle, please take a moment, snap this QR code. What we'll have is we have product information up here. If you're interested in Radicle Lab or GeoPress, or if you're interested in crop response, becoming a partner, or interested in our webinar we're going to have the week of February the 10th. And just a shout out for, if you like this type of content, we do an event in the summer called Summer Agronomy Conference where we do similar content like this for a whole day. So please stay involved if you're interested. And now I'm going to turn it over to Cory to talk through what the application looks like.
Okay, so we've talked through opportunities to increase the accuracy, the repeatability, and the value of the data that comes from your soil test and your lab process. The next phase is you're going to sit down with your fertilizer agronomist and you're going to evaluate the results and put together the full investment of a fertilizer program that you're going to implement after all of the steps have been taken. I was a fertilizer agronomist doing the recommendations for about 5 years before it came to precision planting. There's about 3 ways that farmers would approach the meeting to talk about their fertilizer recommendations. One is some farmers would come in, arms crossed, frown on their face, eyebrows dipped down, kind of look like they were upset before we even started the meeting. And they would approach this conversation as, I don't really care what your numbers are, I need to cut $50 out of our fertilizer program, so just make it happen. Okay? I get it, there is a budget that we have to be mindful of. Another version, guys would come in and they would say, whatever you came up with, I trust the soil test process, I trust your recommendation, they just write a check. Fertilizer is important in a cropping system. They didn't ask a single question about how we came up with the results or how we prescribed the fertilizer to be applied. And then a third way, which I think is probably a better approach of the 3, and that is farmers would come in and they would have a student mentality. They would ask questions. They would say, can you show me areas on my farms where we've got poor soil test values? Maybe we could attack those this year and hold back on some of the zones that have higher fertility values because we know it's low risk that it would impact yield if we pulled back on the fertilizer in those zones. And you could manipulate and create a better overall scenario to address the soil test values and the recommendations. The reason why it's important is it's a pretty big financial gamble, and there's a ton of error and a ton of variability in how these recommendations are put together, like you've seen so far in this session. Your fertilizer bill could be as high as $200 an acre for just 1 year. So for a 1,000-acre grower, it's $200,000 that we're trying to implement how to distribute this investment. If you're a larger 10,000-acre grower, it's $2 million in this 1 year that we have to make a decision on how we're going to distribute this investment. So it's quite a gamble, and you should really strategically approach this whole process and be more involved. From an agronomic perspective, at the top of your mind, you should be thinking about how do you meet the crop's needs for your nutritional program. Fertilizer use efficiency, FUE, should be in your language at all times when you're talking through your fertilizer management process. When it comes to corn, there's 4 key times of the growing season that we need to make sure all of the adequate nutrition is available to the plant. Number 1 is we need quick uniform emergence at the beginning of the season. Then we need to make sure that the nutrition is in place so that we get adequate ear development during the V4 to V7 growth stages. We need to make sure we get adequate kernel development when reproductive stages start in the crop. And then at the end of the season, we don't want to run out of fertilizer. We want to make sure we have everything needed to maximize kernel development, to get depth and test weight, to finish out that top end of yield and get the best ROI. Now this entire screen is the crop cycle of corn. That's not your whole year. Here's what that crop cycle looks like in a 12-month calendar, okay? So the next thing is not just when the crop needs it, it's also understanding the timing of when you put fertilizer in your fields matters and how efficient the crop is able to get a hold of that fertilizer or have it available when it needs it. So that crop cycle is less than half the year, and you see that color chart above the crop cycle is the fertilizer uptake throughout the growing season, and you see it hit that really steep upward curve, and you get this massive uptake of nutrients right about the time that the biomass is really growing rapidly. That's when we need to make sure we have plenty of fertilizer available. Well, fertilizer that's applied the fall before your crop growing cycle is as much as 8 months before the crop really needs it. So there's a significant opportunity to increase the use efficiency by the crop by thinking about the timing at which you're placing your fertilizer in the field. Fall broadcasted fertilizers are a good tool for managing the soil test levels in the field. It's the nutrient density within the soil itself That's what the roots will get access to get the fertilizer it needs over time. But the reality is, and something you should always be considering, is that the majority of this fertilizer is consumed by the soil itself. The clay lattices, the organic material, the humus, and the soil microbes consume the majority of the broadcasted fertilizer, and it's on their terms that nutrients will be released to the crop. That release cycle then is the nutrient cycle in the soil itself, and it's heavily driven by the weather patterns that we experience year in, year out. So your dry periods versus your wet periods significantly play a role in the ability of the soil to release the nutrients that are stored in that soil. So it's not a real reliable system. We can gain a lot of efficiency by taking a hybrid approach and reallocating some of the fall program nutrients into bands applied by the planter or a side dress toolbar or a strip till bar to increase the placement and timing and efficiency available to the plant. Two nutrients that have a huge opportunity in giving you a better ROI by better placement and timing are nitrogen and phosphorus. Phosphorus is often tied up in the soil and hard to get access on a regular basis by the plant, and nitrogen is just a mobile nutrient that is hard to hang on to throughout the season, so moving it to a band and in season is a big opportunity. These placement methods that you see for phosphorus and nitrogen around that corn plant can be achieved with a couple of products that we came out with a few years ago, FurrowJet and Conceal. And we've got a lot of research showing the value of FurrowJet and Conceal. FurrowJet is the triple band applicator in the dark orange right down the center of the furrow, one band going in furrow and two bands going on the sides of the furrow in the soil. And then Conceal is the blue band, which is 3 inches on either side of the row, which is an optimum placement for your nitrogen. FurrowJet, closer to the furrow and the seed, is your phosphorus type product placement. We've got 10 years of research trials evaluating the opportunity on the farm of moving phosphorus fertilizer from fall broadcast to FurrowJet banded application with the planter to give you that early pop-up and starter effect. After 10 years of side-by-side trials, we're averaging a 9 bushel per acre advantage and $34 an acre increased profitability with phosphorus reallocation programs. When it comes to nitrogen, we've also been looking at what the ROI and yield opportunities are in placing the nitrogen differently in a crop season. So this example is an average of 8 years of doing this nitrogen placement trial at our PTI farm. The baseline application program is a fairly standard program here in Illinois, which is about half of the nitrogen getting applied with the sprayer with a weed and feed program, and then the other half getting applied with the side dress applicator at about V6 corn. So that is your baseline. That's 1 plus 3, the black line right across the middle. And then the other programs are looking at the ROI of the same nitrogen program, just applied differently. So the red bar is 100% of the nitrogen broadcast with the weed and feed. And you see it's not a very efficient method to feed the crop nitrogen all year. It's losing $32 an acre in comparison to the standard program. The light blue is 2 plus 3, which is planter banded Conceal nitrogen and side dress nitrogen, and we are $23 an acre more profitable than the standard program. And then the last one, the green bar, is when you use all 3 machine passes. And what's interesting about these machine passes is these machines are making a trip over your field every year regardless of whether you put fertilizer on them or not. So by utilizing all 3 passes, we're actually $47 per acre more profitable with the same pounds of nitrogen in these programs. The other interesting thing is just seeing the opportunity of how much it matters with how and when you place the nitrogen. There's $80 per acre difference across all of these programs just in how and when they were placed. This study is bringing together both reallocated phosphorus with FurrowJet and reallocated nitrogen with Conceal and comparing it to traditional, more broadcasted programs. So the left-hand side is the standard program. Nitrogen's going on weed and feed with the sprayer and side dress, and all of the phosphorus is being applied in the fall with the floater truck. So from a nitrogen perspective, the banding reallocation program, we're shifting the sprayer nitrogen to the planter, and then we're keeping the side dress nitrogen about the same. For phosphorus, we moved about a third of the program to FurrowJet on the planter to meet the early emergence needs of phosphorus. And we also moved about a third of the phosphorus to the side dress applicator. We can just blend that in with the liquid nitrogen in the side dress applicator. It's a great tool to put some phosphorus banded between the row. And then the floater truck on that banded program is only applying broadcast fertilizer where the soil test values need some build phosphorus. So that's where the DAP or MAP is going. We've been doing that, or we did that on 3 farms, almost 200 acres on these 3 farms, highly replicated across these farms, and we did it for 5 years. And this chart is the 5-year corn-soybean rotation average increase in ROI of fertilizer of the banded program versus the more traditional, heavier broadcasted program. And you can see the range by all these different soil zones and soil types on these farms is somewhere between $40 and $150 an acre more profitable, but always more profitable than the broadcast. The overall average is just under $90 an acre more profitability by implementing some reallocated phosphorus and nitrogen to planter and side dress passes. So timing and placement is a big opportunity to increase your ROI. Now, when it comes to application accuracy and monitoring, traditional systems with liquid fertilizer are not very useful. They have a lot of room for error. We did some studies on a traditional control system, and we found that there's as much as 27% rate error row to row on a liquid applicator. Out in the field, just a 2-mile-per-hour change in ground speed as you're applying the fertilizer can create a 20% error in the rate that's actually being put out by the pump. So we came out with the MHD a few years ago, which is an electromagnetic flow meter that goes on every single row output for a liquid system. And it also has a ball valve. So you get the same control and monitoring that you're used to with your seeding on the planter. You get row by row rate, row by row swath, row by row monitoring, and you get turn compensation for the whole tool. What about granular fertilizer in the fall? Are there opportunities to increase the efficiency with the granular fertilizer applications? At the PTI farm, we started doing a multi-year study looking at the broadcasted P&K program versus a banded P&K program. So it's a phosphorus and potassium blend of granular fertilizer. We're doing it all with strip till. So the broadcast blocks are getting the strip till tillage, but no banded nutrients. We broadcast over the top afterwards. And then what you're looking at in this 4-year average return on investment, we're 4 years into this study, these are the increased profitability of the banded blocks as compared to the full rate broadcasted blocks. So the percentages across the bottom from left to right are the rate of fertilizer. 100% is pound for pound the same as the broadcast program. And as you move to the right, then it's a 75% of that program, 50 and 25%. So you see, even all the way over at just 25% of the same amount of fertilizer as the broadcast, it's yielding a little bit more and it's more profitable than the 100% broadcasted rate. But the optimum is showing us that about 75% of the broadcasted rate is yielding the highest profit at $28 an acre, that second bar from the left. So we're going to continue this. Hopefully we get 10 years of data on that broadcast versus banded. When it comes to granular application tools, we also have a Clarity system, which again, similar to the liquid system, Clarity gives you planter seeding-like accuracy and feedback for monitoring and control. So you get row by row flow rates and monitoring, you get swath control, you get turn compensation, the whole works with a granular applicator. So the challenge is, do you know where you're at with your fertilizer program? How do you know if you've got the optimum amount of fertilizer and you're maximizing the return on investment and the yield potential? In my crop scouting days, we would look at a field like this one in the picture and we would evaluate it from a perspective of what's the color, the uniformity of the color, the uniformity of the size of plants. Are there any patterns? Are there any pockets or zones that are off in color or size or uniformity? This field looks pretty good. Do you know, based on this picture, if it has enough fertilizer to optimize profit and yield? Maybe if I give you the soil test values, you might be able to come up with an answer for this question. Soil test values on this good Central Illinois farm is 4.8% organic matter, 27 CECs, 25 part per million phosphorus, 190 part per million potassium, and a pH of 6.8. If you don't know soil test values, those are really good numbers. That's right where you want to maintain and manage a field to have adequate nutrition. So is this field optimized? You might assume so, but it's still pretty hard to have confidence in answering that question. Maybe if you knew what we applied, because all the fertilizers on for this year, we put on 170 pounds of DAP in the fall, 100 pounds of potash went on in the fall, broadcasted, all of those. In the spring, we put 60 pounds of nitrogen on with the weed and feed, and then in the summer, about V6, we side dressed 100 pounds of nitrogen. So do we have the optimum rate and placement to get the best ROI on this crop? Still hard to tell, right? Brad mentioned the opportunity to do research on your farm. This happens to be a field where we did the broadcast versus banded programs, and it's not until you learn for yourself and you compare what things that you hear in the industry, right, when you go to conferences like this, that there's better opportunities. That block on the left-hand side is the planter banded block where we reallocated some of the nitrogen and phosphorus to fertilize and conceal on the planter, and you can see that the corn is healthier, bigger, greener. We enhance the emergence, we enhance the ear development on that side, and those are the types of visuals that we typically get when we see those positive yield and economic results. So how are you applying your fertilizer budget? How you apply it really matters. Challenges we want to send you home with here at the end, like Brad said at the beginning, we want you to start taking more ownership of the entire fertilizer management process from measurement all the way to the recommendation and the application. Build a more strategic soil sampling plan. You should have full confidence and knowledge of every location that samples are being pulled in the field, and you want to evaluate it from a perspective of, are all of the unique soil types and zones and yield zones being represented well within the soil sampling strategy? If not, you should suggest change or demand change. Consider how accurate your results are and pursue more accurate results. The Radicle Agronomics system is commercialized now. It's getting out into the market. You can start having conversations with your agronomist about how to get your samples analyzed in a lab that increases the accuracy and reduces the error. Get your fertilizer strategy on the right line. Play the game of pickup sticks with your fertilizer agronomist and make sure he understands your risk tolerance and how aggressive you want to be with your fertilizer management. And then optimize and maximize your fertilizer use efficiency through choosing better timing and better placement of your applications. So that concludes our session. Thank you.